this week's live stream. Learn how to add your own crazy contraptions to our Chromeworks Rube Goldberg machine. Ben shows you how to make your Scratch games more mobile friendly. And we preview a cool new drawing game that we're developing in our summer coding clinic. All this and more coming up. Good morning, world. It's Mr. Tomac back again with the weekend Chromeworks live stream. Boy, it's been a busy week for us here. I was live streaming every day this week except for Friday. For Monday, Tuesday, Wednesday, and a little bonus episode on Thursday, we were doing Mr. T's Code Clinic, which is my new summer program where I am basically live coding. I'm making projects and working with kids all over the world developing stuff. This week we did two different projects. I'm going to show you both those projects, and we'll learn a little bit more about what we did this week. And that's kind of the theme of this week's weekend live stream, is we're kind of reviewing what we did during the course of our daily live streams. We're going to be back again next week, starting Monday at 10 o'clock. With even more live stream fun. So if you want to see the nitty gritty of how a program is made, it's not always glamorous work, of course. We get stuck on things, we grind to a halt every once in a while, and things are never as smooth as we think they're going to be. But that's part of building code, and that's part of what really makes this such a high wire act when you're doing it live. So I really enjoyed my first session. I'm looking forward to going back and doing it next week. I think we're going to be doing some storytelling next week where I'm going to be creating a digital story, basically bit by bit, with help from students, and especially with suggestions. So I'm going to ask you guys to sort of pitch in and help suggest what kind of crazy dialogue and characters and stuff we're going to have in our stories. So please chime in if you have any ideas for stuff we'd like to do. Well, so I'm joined on the stream here by Gamer Davey, who was with us all week this week, working on the live stream, and he really showed us some of his coding chops this week as he was helping us develop this Pictionary game that I'm going to be showing you. He actually had some really great ideas and really contributed to the stream. So good morning, Davey. And we're also joined from Florida by Thane. Good morning, Thane. How are you today?
Good morning, Mr. T.
So what's new with you? You said that. So Thane was just telling me offline that he's working on a board game, an actual solid board game made in the real world instead of a video game. Hey, tell us all about it, Thane.
I love Terra. It's basically this like game, and there's also a TV show about it where there's this world called Slug Terra, and where like a bunch of slugs live, and people like use them in battle. Like they shoot them out of a slug slinger, they shoot them out of a like a slug gun or something, and then they transform into like a beast. And then when they collide, they like do damage and stuff, and then they try to knock each other out.
So this board game's gonna be kind of combat between slugs. Is that what you're telling me here, Thane? All right. Okay. And is it going to be like cardboard pieces moving around, or are you going to design your own pieces somehow? What are you going to do about moving stuff around? Oh, wait. I'm getting crickets here. Sorry.
Maybe.
Yeah, sorry. So, Thane, I was asking you, are you going to be like designing your own cardboard pieces to move around, or how are you going to do game pieces?
It's just going to be like a bunch of paper that laminate, probably just going to be all the pieces.
Okay, a little bit. Okay, so laminated pieces of paper. Okay, that makes sense.
The board is like the board and the pieces, like they're all flat. Like the board is just made out of a bunch of cards.
Right. Excellent. Well, we're looking forward to seeing that, Thane. We'll definitely send us some pictures, and we'll watch your progress of your game as it's coming along. That's great. I'm also joined by Ben, my former co-op student and now my partner in crime. Hi, Ben. How are you today?
Hey, how's it going?
Good. So this week we got Ben working on another Ask Away segment. We had one of our students online asking about how to turn a Scratch game into a mobile game. And so you had to do a little bit of research to figure that out yourself, I guess, Ben.
Yeah, no, I did a lot of playing around, but it was fun.
Yeah, yeah. We're getting ready to release part three of your Smash Brothers tutorial, so we might as well get right to that part of the tutorial anyway. I just want to show you the show everyone out in the world here the mobile version of Super Smash Brothers that Ben has put together here. Let's get right to that right now. So this is the mobile edition of Super Smash Brothers. I will give you guys a link to this in the chat. By the way, if you're lurking in the YouTube chat, do please stop by and say hello, and we'll give you a little shout out on the stream. I'll post it into Discord as well if you guys are interested. So this is the mobile version of Super Smash Brothers. Tell us about it, Ben. It's not really a fully functional game, is it? Ben?
No, it's just kind of the characters, just a few characters, and then just working around. I didn't go and program the whole thing, so I would have had to program like an AI and everything.
Of course,
and I didn't really have time for that, so I did a little less.
Yeah, it looks really cool here. So it's got some great little controls here that you can control with your thumbs and just by pushing buttons here. So Ben's going to tell us all about how this works right now. I just wanted to invite the world to have a look at this. I think that Ben actually did a really great job on this. We'll have a look at some of the coding in a second as well. But let's jump right to Ben's Ask Away segment here, and he'll tell us all about how he made this project.
Hey guys, welcome back to episode 2 of Ask Away, a newish segment where we answer questions from you guys. So, if anyone has any questions, drop a comment on any of our YouTube videos or Scratch projects, and we'll get back to you with a new episode as fast as possible. So, today's question is from ProLearner. Hey guys, welcome back to episode 2 of Ask Away, a newish segment where we answer questions from you guys. So, if anyone has any questions, drop a comment on any of our YouTube videos or Scratch projects, and we'll get back to you with a new episode as fast as possible. So, today's question is from ProLearner, who asked...
Okay, we had a bit of an issue there, eh? The video started playing twice, and I'm not quite sure what's going on there. I think I'm going to play this manually, and I'm not quite sure what's going on with my software here. Sorry about that, guys. Yeah, I'll just play it right on my screen here the old-fashioned way with my video player. So I'll get to that right now. Once the program loads. Oh, I'm having some computer issues today, guys. It is not pretty. I'm still waiting for my video to load. I might have to do the dreaded Windows reinstall in the next couple of days, I think, just to make sure that, because everything is turned very, very slow here.
Hey guys, welcome back to episode 2 of Ask Away,
and now I'm
a newish segment where we answer questions from you guys. So, if anyone has any questions, drop a comment on any of our YouTube videos or Scratch projects, and we'll get back to you with a new episode as fast as possible. 2 of Ask Away, a newish segment question where we answer questions who asked, I'm using an iPad. How can I make this game mobile friendly? Now, this question was pertaining directly to our newest project, Super Smash Bros., which creates a few issues. Now, the reason you can't actually play it on your iPad is because we use WASD to play it, but iPads don't have keyboards, so we have to do something like this, and use built-in buttons to move. But since Chromeworks' original Smash Bros. Is a 2-player game, things get a little cramped. But we could just make it single player, which is kind of what I did here. Now, this is the same game as before, just taken down a notch. So when I say taken down a notch, as you can see here, we click to continue, just like the regular game, we only actually have 2 characters, and we're only playing as Link. So we can use this little pad over here to control where Link goes, we can drag this thing wherever we want to go, using the things here, like that. And of course this works much better on the mobile, so if we're actually on iPad, it runs much smoother, so we can actually use our thumbs to do this. And then of course we have buttons where we can jump, and of course we can double jump, triple jump, do all that stuff there. We have buttons to block, and yes, I have added in a new cool animation. Then we can also attack and do things like that. Right now we just have it so Kirby's just attacking, or Kirby's just standing there, and I can just attack Kirby all I want. I can attack Kirby wherever, and Kirby's just gonna take a bunch of damage. So it's definitely not like the real game. We can just turn Kirby off for now. So let's actually quickly take a look on how I programmed this. So first I'm gonna go to big screen here, and as you can see there's a big list, 1, 2, 3, 4, 5. And each one of these corresponds to a different thing Link could do. So if we start playing over here, like this, there we go. So let's say Link wants to run this way. As you can see, the position 1 is gonna change to 1, and as soon as I don't, it's gonna go back to 0. Same if I want to run this way, the 2 goes to a 1, and then as soon as I don't, it goes back to 0. Let's want to jump. You can briefly see that the third position is gonna quickly flicker. This guy quickly flickers whenever I jump. So that's it, changing to a 1 and then changing back. If I hold down the jump button, it'll actually stay at 1, but it kind of goes a little weird. I could also block, which would change position 4 to a 1, or it could even attack. That would change position 5 to a 1 briefly. So each one of these things, the buttons will then change the position here, and then once Link realizes the number has changed, we'll then do whatever we want it to. So if we go over here, as you can see the jump button, that's position 3. Whenever we're actually touching, whenever we're clicking down the jump button, it's gonna of course play our sound jump, and it's gonna replace item 3, so the third part on the list, with 1, and then if not, then it's just gonna change it to a 0. So it's the exact same for the block button, it's the same bit of code over here, and it's the exact same for the attack button. So if I go to Link over here, if you wanna know how to code any of this, make sure you check out part 1 of Chromeworks tutorial, and it explains all of this and how to do it. But for this part here, this is a little bit different. Instead of checking for WASD, so if we're moving up and we hit the W key, we're checking if that item in the list has changed. So let's say we're walking, so that's number 1 here. We're gonna point in that direction, 90 degrees, and then we're gonna go and we're still gonna do our walking animation just like before, except now we're detecting if item 1 of Link changes to a 1. So that's kind of how it works, and I hope I answered your question. If anyone else has any more questions, make sure to get in contact with us, and I really hope someone gives it a shot and maybe tries to make the original Smash Bros. Game into a mobile game with AI and everything. Thank you guys for watching. I'll see you next time.
Okay, so sorry about all the technical glitches today. I'm not quite sure what's going on with that video and why it played twice. I'll have a look at that later. Anyway, so we're having a deeper look at Ben's game here now. I'm actually really curious, especially about how this joystick function works in here. So, Ben, are you still with us right now?
Yeah, I'm sorry.
Yeah, okay, so the buttons where they're just an on-off position make a lot of sense to me, right? But with this joystick, we're looking for X and Y positions here. So this is activated if this little Joy-Con circle gets moved beyond its start position, right? So it's triggered when you, as soon as you move it out of its home position, is that right?
Yeah, as soon as you move it away from the center, it's going to trigger, which maybe I should have made the coordinates a little bit like more spaced apart. Sometimes if you move it a tiny bit, it'll go, but yeah, if you move it away, then it goes.
That's interesting. And how does it determine an angle? I'm still trying to have a look at this and see. So if I press up, for example,
Yeah, sometimes it goes weird like that if you like try to drag it on the smaller screen.
Oh, and you have to play it on the, yeah, okay, that makes sense, right. So yeah, all of these games have to be played in big screen, otherwise the layer order and everything gets messed up. So if I go up and to the left here, for example, this thing is only really recording left-right movements, I guess, so you're really just recording your export, and is that right? Or
yeah, I was gonna have it with the up and down, and then we jump and block, but I kind of want to just add more buttons, so right. I made a left and right.
So as soon as I move it beyond its left position, it just gives, it just changes or sends a message to change its X position. I'm seeing it here. Interesting. So it just replaces it on the list, and where is it reading the list from then?
That's inside Link.
So if I go to Link's character here, and
then scroll down.
Mm-hmm.
And that guy there. So it's 1 and 2. So it's the last guys at the bottom when it says when I receive start. So the 2 and the 1 is its walking animation. Oh, you missed it.
Oh, I missed it. Sorry.
And it there it is.
There, yeah. Oh, I see. Okay, interesting. And so it's getting. Oh yeah, if item 2 of link is equal to 1, then we point in the direction. Interesting. Okay, I get it. Well, very cool. Anyway, yeah. So it's not a game that lends itself well to mobile, and that was the unfortunate truth that we had to tell to our questioner, of course, because we don't have an AI in the game. But you can definitely see how you can apply this to almost any game. So I'd be curious to see if anyone else can modify an existing game using this mechanism and create some kind of a mobile-friendly game. So please shoot your mobile-friendly games over to us. We would love to see it, especially if you can take one of my older Chromeworks titles and convert it over. I'd be very happy to see that. All right, so as I mentioned, we are releasing part 3 of Super Smash Brothers at 11 o'clock today. So Ben, I think, as I understand it, we're getting most of our characters done. To give us an overview of what comes up in part 3 here.
So in part 3, we're getting all of our menu things done. So we can actually get it so you can go and select your arenas, you can select your characters, things like that. And we have the jetpack working and all that. So the last part we have to do is in part 4. The only other part is to do our little game over and finish the rest of our characters.
Excellent. So that'll be coming next Saturday. We'll be wrapping that up, and then we'll be happy to bring you another project. All right, guys. So still not seeing anyone over on YouTube. It's a slow day today. I guess we're in summer mode here today. So I wanted to tell you a little bit more about this summer coding camp that I've been running. It hasn't been super well populated, but I've had a couple of my hardcore users there, including Davey, as I said, and Funny Animator Jim popped in for a little bit, and we had 1 or 2 other people drop in as well and give some ideas. I'm going to keep running this, at least for the next little while, but if I don't see more people show up, I'm not sure how long I can sustain it. One of the good things about this program, though, is I've been able to develop stuff that I can turn into other tutorials. So we spent the early part of the week working on a project that Jeffrey had compiled for me. And so he did most of the heavy lifting in the coding. It's called the Infinity Machine. And I wanted to tell you guys all about it. So the Infinity Machine is an engine, or basically a building block for creating your own Rube Goldberg machines in Scratch. And I have an example one here that I want to show you guys that kind of gives you an idea. So when I click the green flag here, a ball hits a hammer, which hits the cage, which makes the mouse go, which pops up a toaster, which hits a truck, and the truck falls off a cliff. So we coded this all during our first couple of sessions, Monday and Tuesday. And the really cool thing about this project is, even though there's quite a bit of complex code in it, it's not difficult to make your own objects. So you don't have to understand the code in order to add objects. You simply have to pick a graphic and add a few simple commands to it using some custom blocks that we've created. So we made this so that it's quite complicated but easy for users to use. So I've got a little tutorial here. I'm hoping that since we didn't have too many people show up for my weekday live streams, that we would be able to show this today on the weekend live stream and maybe get some more people building with this, because I really would love to have other students create components for this so that we can create a gigantic Rube Goldberg device. This is called the Infinity Machine for a reason, because we can just keep adding and adding and adding to it. I don't know if you guys remember the Chromeworks parade that we did at Christmas time, where everybody added floats to our parade. And I want to do something similar where everyone adds components to this device. So I'm going to do a little quick tutorial here explaining to you guys how to add pieces to this device for those of you who missed it, which was most of the world. For those of you who missed it, let's have a look right now at how to do this. I'm also going to be releasing this as a separate standalone movie a little later in the weekend as well. So I would love for you guys to follow this tutorial and figure out how to make one of these devices yourself. Here's my tutorial right now. Let's pray that it works. Hey, it's Mr. Tomac here, and today we're going to be programming a Rube Goldberg device. That's a very complicated machine that does a really silly job that's really unnecessary. And it works on this idea of a chain of events. One event causes another event that triggers another event and makes things happen. Now there's some very complex code inside this project, but the good news is you don't really have to understand it to make your own Rube Goldberg device. We've designed this project to be modular so that all you have to do is add a few little blocks to some custom blocks to make things move and rotate and change costumes, and you can make your own Rube Goldberg device. So follow along with me, and I'm going to give you all the steps you need to know to create an awesome infinity machine. So most of the code you'll be working with in this project is contained inside this object sprite. I just have a generic graphic set up here right now, but you can see that there are other graphics attached to it that you could choose to use in your projects. There's a hammer, a bellows, which is a machine for blowing air, and a boot attached to a stick, and a few other kind of typical objects that you would find inside a Rube Goldberg device. So for now, we're just going to use this generic object just to see how the functionality of it works. So this sprite, the object sprite, contains all the code that you're going to need in order to make your Rube Goldberg components work. The code over here on the right, none of this has to be modified at all. This is the real guts of what makes your project work. You don't really need to understand what's happening in here. You just need to use these blocks by deploying these red custom blocks that are over on the left here. So I'm going to show you one by one what each of these custom blocks does. This custom block called animation is where the real action is going to be happening. This will dictate how your object moves, what costumes it's wearing, and what sound effects it's going to be playing as it goes through its cycle after it's been activated, basically. So right now, by default, I just have my object moving 2 pixels across the screen 75 times. So it's moving 150 pixels across the screen. You can see that in action by running the program. Let's maximize our screen and click the green flag. And once you're ready to start running your simulation, just click on the start button. You'll see our object moves at 75 pixels across the screen and then strikes the next object and then the next one. And right now I have the same object striking itself 3 times in a row here. You can see that I've created this object 3 times, and we can actually see that over in the controller sprite, which is the master sprite that controls all of the different clones that we're creating in this code. Those 3 instances of the generic object that you see on the screen are being created over here in the controller object under this custom block called create clones. And you can see that we created 3 versions of the object. As we add more objects to our Rube Goldberg machine, we'll create clones of them here in the order that we want them to be created. To create our own objects to add to this Rube Goldberg device, we're going to have to use all the code inside this object sprite. So let's start by making a duplicate of our sprite. I'm going to want to rename this sprite to something that makes a bit more sense. I'm going to replace this generic object with a mouse, and that's going to be our first object that we're working with here. So I'm going to rename this object mouse. And then I'm going to go looking for a mouse graphic to plunk in here. So let's go to our costumes menu, and we're going to choose a costume. And I'll search for a mouse. Now we're going to want both mouse costumes because we're going to want him to cycle through his animations here. There are a couple of other sample devices here, but we can get rid of those now that we don't need them anymore, so that we're just left with our 2 mouse sprites here, and then we'll be able to use the next costume with this code. I'm going to want to have this mouse move in a 45-degree angle rather than moving straight the way that our generic object is. So I'm going to start its initial setup here to be pointing in a direction 45 here, just like that. I could also change its costume or do anything else that it needed to do to initialize its position before it starts moving here in this spot.
Next, I'm
So our
going to change
character's
its
already
movement
moving
coordinates
to the right by 2 pixels every time. To get him moving at a 45-degree angle, we just have to tell him to also change his Y coordinate in here. So we can't just point our character in a direction and use move commands the way we normally can in Scratch, because we have to fix everything inside this virtual world. These XY coordinates are happening across a giant screen that might be thousands and thousands of pixels across, far beyond the edge of this screen. So X and Y, meaning the X and Y positions that are dictated by these blocks, don't work inside this world. The only way to change coordinates is by changing the X and Y in these custom variables here. So because they're happening simultaneously, we're moving to the right and up at the same time inside the same loop here without having any delay in between them. These two are going to happen simultaneously, and it's going to make our mouse appear to move diagonally. To see our mouse in action here, we're going to have to add to the game, and we're going to do that inside this controller sprite right here. Let's click on it here, and you can see we've created 3 iterations of the object here. I'm going to change the first one to mouse so that we see a mouse on our screen. And now let's click the green flag, and you'll see that as soon as the music dies down and we click the start button, a mouse will appear on the screen and move diagonally across the screen. Now he's not hitting the object the way that we want him to. The object is just starting here in the middle and doesn't seem connected to him at all. And this is where we have to set these marker input points. I've got 2 of them here, a green one and a red one, and these dictate how objects hit each other. So we're basically going to want to set this mouse up so that when he ends his movement, his nose is going to be touching the tip of this object. Now something could be touching the mouse to get it going to, and so that's why we have to designate a start point for our object. That's the spot where it's going to be hit, and then an end point, which is where it's going to end up after it moves. So we can set that start and end point over in the mouse sprite by clicking on this apply coordinates custom block. Now your game must be running for this to work, so make sure you've clicked the green flag, and then when you click apply coordinates inside the mouse sprite, you'll see our mouse character is sitting here in the middle of the screen. I've got a green dot here that's attached to my sprite, and I'm going to click it on the spot where I want my mouse to be activated when it gets hit by whatever it is that hit it before it in the cycle here. So I'm going to click right on the tip of its tail where I want it to be struck. Then he's going to run through his animation. You can see that we're moving diagonally here. I have to make sure my movements are not so much that he'll go off the screen though, or this isn't going to work. So all your movements have to be quite small here for this to work. Now you can see that my cursor is turned to a red dot here. I want this red dot to be the spot on my mouse where he is going to hit the next thing that he hits. In this case, it's that little square object block. So I'm going to click on the tip of mouse's nose here, just like that. And then my program's going to reset itself. So now when I run my program, it should hit, let's go back to our controller object. So we've got the mouse being created, and then when it ends the animation, there should be a square object there that it hits with its nose, and then as soon as that happens, it will be, the object will start moving. So let's have a look at that right now. So we click the start button, and the mouse moves, and then whacks into the object, which gets it moving, which gets it hitting the next object, which gets it moving. Perfect. Now let's add a little bit more pizzazz to our mouse's actions here. I'm going to tell him every time that he moves to do a little change costume here. So I'm going to go to my looks commands and add a next costume. That'll get him wiggling his little tail. Make sure, of course, that you've gotten rid of any additional animations in the sprite so that we only have mouse sprites. Otherwise, you're going to have your mouse turn into all sorts of unpredictable things. Alright, I'm also going to add a sound effect here. So before I start my repeat cycle, I'm going to start the sound off. We don't want it repeating itself. I've just taken the liberty of loading up a sound file here called squeak. So let's have that sound start right at the beginning of the animation. So next up here, I'm going to program my mouse to do something after he's finished striking the next object. And that's where this custom block called after animation comes in. Anything you program here will happen after the action moves on to the next object. So in this case, I'm just going to have my mouse rotate and take another few steps before he actually stops here. So I'm going to tell him to turn kind of 90 degrees to the right here. We're going to do that just by having him repeat 30 times and change his rotation by 3 degrees each time here. That'll end him up at a 135 degree angle where he's facing down and to the right. So we're going to have to tell him to start moving once he gets down in that direction, and we're going to want him his x coordinates to change. So let's put him inside another loop here, and we'll have him repeat maybe 20 times. And inside of this little block of code here, we're going to want him moving down and to the right here. So let's go and tell him to change his x coordinates, which again we have to change with these blocks here. We're going to tell him to change his x by 2. And we're going to want him to change his y coordinates too, but instead of changing his y coordinates by +2, we're going to want to change it by -2, which will get him moving down the screen. So the combination of those two blocks will get him moving down to the right 20 times. Let's have him change his animation inside there as well with the next costume. And then we'll just have him stop moving at that point, so the code will just peter out. Let's check that out again. And there goes our mouse. He hits the object, and then he turns, and then starts moving in the other direction a little bit. Beautiful! So that worked nicely. If you wanted him moving farther than that, we could just increase that number. Let me change it up to 50 here, for example. And let's watch that working again. Beautiful. One other touch I'm going to add here is while he's turning, I still want him to be changing animation as well. So let's shove a next costume inside the turn here as well. And that extra little detail I think will improve things quite a bit. So our mouse is moving around, and yeah, he scurries his little legs around and then moves a little bit further while these guys start moving. Perfect. Now you might have noticed another custom block inside our object here called add prop. A prop is basically an object that doesn't move on the screen but is a part of our story here. Every prop is attached to a certain object, so in this case I'm going to attach a cage to this mouse so that this mouse has a place to start running from on the screen. So to add a cage prop here, the first thing I'm going to do is I'm going to need the prop code from over under this object here called prop. Let's make a duplicate of our prop, and I'm going to rename this object cage. You can add any stationary graphic that you want here. I've created some sample ones for you inside the costumes menu, including a cage here that you can see that's set up here and ready for us to use. There's a few other objects as well here, like a box and a steel girder and a ladder, just kind of typical objects that you might use inside a game like this. Okay, so now that we've selected our costume, the cage here, well, there's no other code that has to change inside the prop object once we've renamed it. So let's go back to our mouse object, and we're going to go to the add prop command, and we're going to add these blocks underneath it here. These just position the prop. We're going to create a clone at the end here, and we're going to call it cage. And we're going to basically put its position down here using these blocks here. This, the way it's currently configured, there's no offset, meaning the cage will appear directly in the middle of the mouse. So let's see what that looks like. There's one other bit we have to add here, and that is under initialize at the very beginning, we do have to add that prop here. So let's go ahead and go add prop. And now, because we created the clone here, that cage should appear perfectly on top of our mouse before he starts moving here. Let's have a look. We'll click the green flag, and there it is. He starts inside a cage. I probably want that cage to be at the front here before he starts moving. So let's change its stacking order here. So under the green flag, I'm going to tell it to go to the front layer. There we go. And that'll make sure it's stacked up in front of our mouse. So let's run that code one more time here. Click the green flag, and you can see that he starts off inside the cage. Beautiful. Now there is an offset function here in case you don't want your object, your prop, to start right inside, right in the middle of your object. So for example, if I wanted this cage to be a little further down on the screen, I could offset it inside the mouse code here by changing its Y coordinates. I'm going to go here where it says add a coordinate to props X. We're going to add Y plus, well actually plus will move it up on the screen. We're going to move it down the screen by adding a negative number. So we could just go Y minus here, but instead I'm just going to tell it to add a negative number. So let's tell it to go minus 20. And now you'll see that the cage will still appear on the screen, but its position will be offset a little bit, and the mouse starts at the top of the cage instead of at the bottom. Beautiful. By the way, you can add multiple versions of the same object to your code. Let's go back to our controller and tell it after it creates the first mouse to create another mouse, and it will automatically create another cage at the same time. Let's try running that code. And there we go, the other mouse is waiting to be hit. And then he hits the next object. Beautiful. Let's try now to create another object that's a little bit more complicated. So I'm going to make another duplicate of my object, sprite, and I'm going to make this one a boot that swings around to kick whatever the next object is that it's going to hit on the list here. Let's change our graphic to boot, and we'll rename this object boot. We're going to want it to appear inside our game, so we're going to go to our controller and have it create a clone of a boot right after the mouse touches it. All right, let's go to the code for the boot and make it do something right now. So we don't want it to move anymore. It's going to stay stationary, but we're going to want our boot to rotate. Now we want it to rotate around the top of it. So let's go back to our costume and confirm that our boot costume is anchored at the top here. If you see, the center point here is at the top of our boot. And so that means that as it rotates, it'll rotate around this point to basically swing around and kick something like this by rotating around this central spot here. Perfect. So now we're going to want to rotate our boot this way. So right now this is at an angle of 90. It's actually facing upright at an angle of 90. So we're going to have to make it start at a rotation minus 90 from that, which is actually 180 degrees. So let's tell it to initialize itself at an angle of 180 degrees. So we'll go to our initialization, and we'll say point in direction 180, and that will get it positioned the right way. We don't need a prop for this boot, so we're going to get rid of the prop code, and we're going to make sure the add prop component isn't added here as well. All right, so now we don't want our object moving, we just want it rotating through the course of 90 degrees or so here. So we're gonna want it to repeat 30 times here, and each time we're gonna change by 3 degrees, and we're rotating counterclockwise. So let's have it turn 3 degrees, and once it's done moving, we're gonna want it to keep kicking. So that's the spot where it's going to hit, and then after the animation is done, we're going to have it keep rotating. So let's move this out of the way, and we'll duplicate this and have this continue rotating after it strikes the other object. All right, let's go and preview that now. We'll maximize our screen. And here we go. You can see our boot's at its start position here, and then it rotates around and hits another object. Now it's not hitting in the right place, so again we're going to have to set up those initial spots for it. So let's run our program and then click on apply coordinates. And so we're going to want it to start in this position when the mouse hits the heel of this boot here. So we'll set the initial coordinate right here at the heel. Then it will rotate around to finish the beginning part of its movement. Of course, it'll continue to kick here, but this is the spot where it's going to hit the next object. So right at the tip of the boot here where we want it to hit, we'll click the red dot, and that will set the project up again. Let's test it one more time here, and this should be hitting that white object boot when it swings around here. So let's click start. Our mouse starts in his cage. He hits that, bang, and then he knocks against that thing. I kind of want a sound effect to happen in that moment that thing gets hit as well. So at the end of the animation here, let's go play a sound effect. I have a couple of sounds already loaded in here, including one that is a wooden tap sound. That sounds like it'll work nicely. Or we could go with a bonk sound. Maybe that one will work better. So let's use that bonk sound, and we'll have it play right at the end of this animation here. So start sound bonk. All right, let's test this out one more time. There we go. And it hits the other object nicely. So that's pretty much all there is to it. Now it's your turn. I want to see what kind of crazy Rube Goldberg contraptions you can create. Share them to this studio, and we'll take the best of them and add them to a gigantic Rube Goldberg device that we're going to be building during the course of the summer, and at some point we'll show them on our live stream. So if you want to add your crazy contraption to our Rube Goldberg device, just remix our file and save your new device into our studio, and we'll do the rest. Have fun! There we go. So, yeah, I'm really excited about this. I haven't, this project hasn't exactly caught fire. We didn't have a lot of people looking at it while we were building it this week. But I really think this is a very accessible, easy project that everyone out there, even beginner Scratch users, should be able to do. So, and it just involves a lot of creativity. So I'm really looking forward to seeing what you guys can create here. This is the remix room, and again, I'm going to save the location of this inside the file description. So if you're looking to save a project to this remix room, here is the address for it. All you have to do is take the URL of your own remix and paste it into this window here and click on add by URL, and then it will be part of this remix room, and from there I will be able to get access to it and add that sprite to my own project. So it's a great little chance to collaborate. So I was mentioning as well that we were working on a second project. Oh, we're joined over on Discord by funny animator Jim, who along with Davey was really active in helping me with this other project, and that is our Pictionary game. Now this is going to be made into a full tutorial in the next couple of weeks. I just wanted to give you guys a sense of the kind of stuff we were doing. So this was a real live coding project that we did. We started off with nothing but this little sprite here, which is a little cursor that we were using, and that's the only thing I gave you guys. And from there we just started building. We used list commands to basically record our cursor movements in this game, and then play them back. And the idea is that we want to watch while we're drawing something and recording our movements, and then play them back again later so that somebody else can guess what the thing is that we're drawing. I'm going to walk you through kind of what that looks like right now. So you can see that I've already gone ahead and drawn a stick figure here. Let's click the green flag, and I'm going to hit play mode, and this is basically what somebody who was playing the game would be looking at here. So you click on play, and you can see that it basically starts drawing. You can stop the drawing process at any time by clicking on the guess button and guessing what it is that we're drawing here. I have no idea yet, but as we continue drawing, you'll see that at some point it'll become clear that it's a stick man. And then at that point, you could hit the guess button, and you'll get a multiple choice question that you can answer. Basically, is this a stick man or a fish or a blah blah? And you'll be able to write those questions as well. So this game's not quite done yet. It's still in development, but I actually think it has a lot of promise. So that this is just another tutorial that I'm working on right now. We ran into some interesting problems coding this, and the number one problem that we had was in figuring out how to take the data where our mouse was on the screen and turn it into a list so that we could write it to a list and then read it back from the list, which turned out to be quite complicated because the list that we were saving information from, let me call it up right here, it's called Drawing 1. It just contains hundreds and hundreds of coordinates here, separated by a comma. So we needed basically the code to record the XY coordinates of your mouse cursor constantly as you were drawing something on the screen, and separate that X and Y coordinate with a comma. Then we used other code to read back this code one line at a time, and again pull the first couple of characters out up until the comma, and use that as our X coordinate, and then grab the next part and use that as our Y coordinate. So it turns out that that's quite a complicated feat. Let me show you the code that we were using to record this stuff. So this is the code that actually records your movements here. And so you can see that when I'm holding the space key down, it puts the pen down and it runs a timer here. So all that this timer does is make it so that it's not adding data to this chart constantly. It's basically adding it twice a second, I think, is the way that we have this set up. And I'll explain this timer in more detail in a future tutorial. But here we are, we're adding to the list. So we're adding our mouse X and a comma and our mouse Y. We're rounding it off, so just in case there's any decimals there. We're trying to keep the number as simple as possible. So we're just adding it to the list and continuing to do that twice a second as we draw something on the screen here. If we're not drawing, then as the first time we stop drawing, we add this little dot, dot, dot to the list, and that tells the code to pick your pencil up so that, let's say if I'm drawing a head or something here, I won't, and I want to move down lower on the screen to a different part of the body, I won't have a line connecting those parts of the body together. So that's how that kind of worked in the code. At the end here, we just asked the author of the puzzle to write some multiple choice questions and answers, and those are interpolated later so that we can generate a multiple choice question for what it is that you guessed here when you did the guess. I'm going to walk you guys through this really quickly. So I'm just going to, as soon as I click the green flag, we're going to erase the stick man when I click record mode here. And now I have a drawing tool available to me. And whatever it is that I choose to draw here is going to get recorded onto that list again here. So I have to hold the space key down to actually start drawing. Let's just try drawing a simple airplane or something here. So we'll start at the bow here, and we'll just go across. Just like that, and maybe draw a little cockpit up at the beginning here. Not the world's best airplane, and then we'll draw some wings. We'll make this like a jet plane. I think those wings are probably too far forward, eh? I never claimed to be an artist, dudes. All right, there we go. There's our airplane. Now I hit the X key to stop, and it's asking me what did I just draw. So I'll say airplane. Down below, it's a little hard for you guys to see, I'm sure. And then it's asking me to pick some wrong answers. So I'll say bird, Superman. What else does this look like as we're drawing it? Maybe hot dog, or a fish, let's say. So those are the choices. Now we save the game and hand it to somebody else is the idea, and somebody else picks the game up and they hit play mode, and then it starts slowly drawing the shape, and a timer will start running. As I said, the game's not quite done yet, but a timer is going to start running at this point, and you can stop at any point and guess what it is. So the faster you guess at it, the better chance you have of getting a high score in this game is the idea. And so as it draws back the airplane, at any point you can stop the process by hitting this guess button. And it says, guess what I drew. Your choices are 1, Superman, 2, oh, this isn't quite right. Anyway, it still needs a bit of work. And if I select the proper answer, which is not even on the screen here, I think it's probably number 2. Let's try number 2. Enter. No, and I was wrong there. So it looks like there's a few bugs in the software, but it is coming along anyway. So I'm going to be doing a full tutorial on how to do this game in a couple of weeks, but I just wanted to give you guys a preview. So this is the fun kind of stuff that we are doing on our live streams Monday through Wednesday next week. So as I said, we're going to start a different project. I think I'm going to wrap this one up on my own because it's just a lot of finicky stuff that still has to be done. But if you want to join me on Monday, we're going to be doing some more live coding, and I think we're going to try our hand at digital storytelling. Anyone have a suggestion of the kind of story that we could tell? I'm just going to get some characters together, and we're going to start putting something together. Yeah, Thane? What's your idea, Thane?
Hey.
Sorry, I didn't hear it. Say it again.
So, Scratch Cat gotten kidnapped by people. I've seen this game, where goes trying to take over Scratch Cat or something. So maybe we could do that.
So Scratch gets kidnapped by who again?
Pico.
Oh, by Pico. Oh yeah, Pico does look nefarious, doesn't he? Okay. All right, so we're going to do a story with the Scratch characters, Pico and Scratch. That's a good idea, Thane. And what kind of setting should we use?
Like a dungeon, like a cave. And one more thing, I feel like how we should get out is you should use code blocks. You should with each other, and when he clicks them, something happens.
Well, that's not a bad idea. And then we'll have to take the code blocks and render them as sprites. An interesting idea. Okay, well, that sounds like a good plan. So that is the game that we're going to start coding on Monday morning at 10 o'clock, guys. I'm looking forward to seeing you there.
On Monday, actually. The last week, there was no Monday class because of 4th of July.
So you will be able to join us this Monday, Thane?
No, not this Monday.
Not this Monday. Okay. Anyway, so if anybody else has any ideas, since Thane won't be there, we're not going to insist on doing that project. But I think that's probably a good starting point. So unless anyone else has a better idea, that's what we're going to be coding on Monday. All right. So I think we're pretty much wrapped up here. Oh, I got some comments on YouTube that I hadn't seen. Big Thinker says, I had doubt about Super Smash Bros. Ultimate as a cloud. Is it a cloud-based game or not? Says Big Thinker. No, it's not cloud-based. It's a 2-player game that's played live. And so the idea is that you just sit at a keyboard with your friend and you play against them that way. Pro Learner, you said that Ben will do a live stream on Saturday, so what about that? Pro Learner, you have arrived too late. If you go back to the beginning of our tape, you will see that Ben's segment on your question, which was how to turn Smash Brothers into a mobile game. We did deal with that. You just showed up late. So that is really sad for all of us. Okay, guys, so I think I'm going to wrap it up for today. I will be back Monday with some more live coding. And as I said, next week, we're going to probably do a little bit more of a discussion of this Pictionary game once I get all the bugs ironed out of it. Please send along your projects if you guys are working on anything. I'm happy to do remixes and show off your projects. So everyone out there in the Scratch community who's building stuff, show me what you're working on, and I'll look under the hood over here on my stream next week. So in the meantime, it was nice joining you guys, and we'll see you